Every atom in your body has been inside a star. The iron flowing through your blood, the calcium in your bones, the oxygen filling your lungs, even the gold in a wedding ring. None of it existed when the universe was born. Long before Earth formed, before the sun ever began to shine, ancient stars lived brilliant lives, forged these elements deep within their cores, and scattered them across the cosmos in enormous explosions. In a very real sense, you are made from the remains of stars that died billions of years ago. Tonight, we're going to follow that incredible story. We'll discover how stars are born from cold clouds of dust, why some shine for only a few million years while others survive for trillions, how they create nearly every element in the universe, and what happens when the largest among them collapse into black holes or explode with enough energy to briefly outshine entire galaxies. The next time you look into the night sky, those tiny points of light may never seem ordinary again. Welcome back to the Snoozing Scientist. Before we begin tonight's journey among the stars, I'd love for you to leave a comment down below and let me know where you're listening from tonight. Whether you're beneath the bright lights of a busy city or fortunate enough to see a sky filled with thousands of stars, it's always wonderful to know where our fellow sleepy scientists are gathering from around the world. Now get comfortable. Take a slow breath, and imagine yourself lying on a quiet hillside beneath a perfectly clear night sky. The air is cool. The world around you has grown still. Above you stretches a darkness so vast that it seems almost endless. One by one, tiny points of light begin to appear. At first, there are only a few, then dozens, then hundreds. Soon the entire sky is filled with stars. For thousands of years, people believed these lights were fixed to a great celestial sphere surrounding the Earth. Ancient civilizations imagined them as campfires of the gods, holes in the heavens, or lanterns carried across the night. They guided travelers across deserts and oceans, marked the passing of seasons, and inspired myths that have survived for thousands of years. Yet the true story of a star is even more extraordinary than any legend ever imagined. Each one is an enormous sphere of incredibly hot gas, so massive that its own gravity crushes its center with unimaginable force. Deep within that crushing pressure, something remarkable begins to happen. Atoms that would normally repel one another are squeezed so closely together that they merge. Hydrogen becomes helium. And in that tiny act of nuclear fusion, an astonishing amount of energy is released. That energy begins an incredible journey. It pushes outward against gravity, creating a delicate balance that allows a star to shine steadily for millions, or even billions, of years. Every star in the night sky is engaged in this silent struggle. Gravity constantly pulling inward. Fusion constantly pushing outward. A balance so perfect that a single star can remain stable for longer than complex life has existed on Earth. And yet, every star, no matter how brilliant, is only borrowing time. For most of a star's life, this balance is astonishingly stable. Gravity spends every moment trying to pull the star inward, crushing it under its own immense weight. At the same time, the incredible energy released by nuclear fusion pushes outward with equal determination. These two forces have been locked in a silent contest for billions of years. And neither side is allowed to win. If fusion were to weaken even slightly, gravity would immediately begin compressing the star. If fusion somehow became too powerful, the star would expand. A star exists because these opposing forces remain in an almost perfect equilibrium. In many ways, a star is not simply burning. It is balancing. Our own sun has maintained this balance for about 4.6 billion years. During that time, continents have drifted across Earth. Life has evolved from simple microscopic organisms into forests, dinosaurs, mammals, and eventually us. Entire mountain ranges have risen and worn away. Ice ages have come and gone. Human civilization, by comparison, has occupied only the tiniest fraction of the sun's lifetime. If the sun's life were compressed into a single calendar year, all of recorded human history would occupy only the final few seconds before midnight on December 31st. It's a humbling thought. The star that makes every sunrise possible has quietly watched almost the entire history of our planet unfold. And every second, it performs a feat almost impossible to imagine. Deep inside its core, temperatures reach nearly 15 million degrees Celsius. The pressure is so enormous that hydrogen atoms, which naturally repel one another because they both carry positive electric charge, are forced together anyway. When they finally collide with enough energy, they fuse into helium. In the process, a tiny amount of mass disappears. Not much. Far less than the weight of a grain of sand. But according to one of the most famous discoveries in physics, even a tiny amount of mass can become an enormous amount of energy. Every second, the sun converts roughly ** 600 million tons of hydrogen ** into helium. Of that, about ** 4 million tons of matter ** are transformed directly into pure energy. Every single second. The numbers are so large they're almost impossible to picture. And yet from 93 million miles away, all of that unimaginable power reaches Earth as something that feels wonderfully ordinary. Warmth on your skin. Light through a window. A sunrise. The energy you're feeling tomorrow morning actually began its journey in the sun's core long before that. In fact, one of the most surprising discoveries in astronomy is that a photon, a tiny particle of light, doesn't travel straight from the sun's center to its surface. The core of the sun is so incredibly dense that photons are constantly being absorbed and re-emitted by surrounding particles. Imagine trying to leave a crowded stadium where every single step causes you to bump into someone who sends you in another random direction. You might eventually find the exit, but not quickly. Scientists estimate that a photon created in the sun's core may spend anywhere from ** tens of thousands to hundreds of thousands of years ** slowly wandering toward the surface. Only after finally escaping does it race across the vacuum of space. That final journey to Earth takes just over 8 minutes. Think about that for a moment. The sunlight warming your face tomorrow morning may have begun its life before humans built the pyramids. Perhaps even before our species learned agriculture. It spent countless millennia trapped inside the sun before finally escaping into space. And after traveling across 93 million miles, some of those very photons will end their journey in your eyes. The deeper astronomers studied stars, the more they realized something astonishing. Stars are not all the same. Some are gentle, long-lived stars like our sun. Others are true giants. There are stars so enormous that if one replaced our sun, its outer atmosphere would stretch beyond the orbit of Mars. Some stars shine hundreds of thousands of times brighter than the sun. Others are so small and cool that they glow with a deep reddish light, barely visible to the human eye. The universe has created an incredible diversity of stars. different sizes, different temperatures, different colors, different lifespans, each one following its own remarkable story through the cosmos. And every point of light you see in the night sky is another chapter in that story. A distant sun, living out a life entirely its own. As astronomers began looking more carefully at the night sky, they noticed something curious. Not all stars shine with the same color. At first glance, they may all appear white. But on a clear winter night, away from the glow of city lights, subtle differences begin to emerge. Some stars shimmer with a soft blue-white glow. Others appear golden. A few glow with a warm orange, and some faint stars carry a deep reddish hue. For centuries, these colors were little more than beautiful details. Today, scientists know they tell an entire story. A star's color is, in many ways, its fingerprint. It reveals its temperature. The bluest stars are the hottest. Their surfaces can reach more than 30,000 degrees Celsius, radiating an intense blue-white light across the cosmos. Our own sun, despite often being drawn as bright yellow, is actually considered a white star. It appears yellow from Earth's surface because our atmosphere scatters shorter wavelengths of light, gently tinting the sunlight that reaches our eyes. Then there are the cool red stars. Compared to their brilliant blue cousins, they seem almost gentle. Their surfaces may be only a few thousand degrees, yet they can continue shining for astonishing lengths of time. And this is where the story takes an unexpected turn. Our instincts tell us that bigger things should last longer. A larger candle should burn longer than a smaller one. A larger fuel tank should power a vehicle for a greater distance. Stars, however, seem to ignore that intuition entirely. The largest stars live the shortest lives. Imagine two campfires. One burns steadily through the entire night. The other erupts into a roaring blaze, consuming enormous logs in a matter of minutes. The brighter fire is certainly more dramatic, but it exhausts its fuel much faster. Massive stars behave in much the same way. Although they begin life with vastly more hydrogen than smaller stars, the crushing gravity inside them creates temperatures so extreme that nuclear fusion accelerates enormously. They burn through their fuel with astonishing speed. Some of the largest stars in the universe survive only a few million years. In cosmic terms, that's barely an instant. Meanwhile, the smallest red dwarf stars burn their fuel so slowly that astronomers estimate many could survive for trillions of years. In fact, the universe is only about 13.8 billion years old. That means not a single red dwarf has ever reached the end of its natural life. Every one that has ever formed is almost certainly still shining today. Some of the faint red stars visible tonight may continue glowing long after our sun has disappeared. Long after Earth itself is gone. Long after the Milky Way has changed beyond recognition. There is something wonderfully peaceful about that thought. While civilizations rise and fall, while oceans slowly reshape continents, while generations come and go, those tiny stars simply continue shining. Patiently, quietly, almost timelessly. The brightest stars, however, live very different lives. Astronomers sometimes describe them as the celebrities of the universe. They are dazzling, powerful, impossible to ignore. Yet their brilliance comes at a cost. One remarkable example is a blue giant known as Rigel, one of the brightest stars in the constellation Orion. Rigel shines with tens of thousands of times more luminosity than our Sun. If our Sun were somehow replaced by Rigel, the Earth wouldn't simply become warmer. Our planet would almost certainly cease to exist as we know it. The oceans would boil away. The atmosphere would be stripped apart. Life would vanish beneath the overwhelming flood of radiation. Fortunately, Rigel lies hundreds of light-years away. From that immense distance, its incredible power reaches us only as a beautiful blue point of light on winter evenings. It's remarkable to think that something capable of producing such unimaginable energy can appear so calm from Earth. Just another quiet star among thousands. That illusion of stillness is one of the greatest tricks the night sky has ever played on us. When we look upward, everything seems peaceful, unchanging, silent. Yet every star is constantly in motion. Atoms are colliding billions upon billions of times every second. Fusion reactions are unfolding deep within their cores. Magnetic fields twist and snap across their surfaces. Enormous storms rage through oceans of glowing plasma. Some stellar eruptions release more energy in a single event than humanity could produce in millions of years. And all of this is happening while the star appears perfectly still. Perhaps that's why the night sky has inspired so much wonder throughout history. Its greatest dramas unfold so slowly, and across such unimaginable distances, that to us they appear almost eternal. But nothing in the universe remains unchanged forever. Even the brightest stars, no matter how magnificent, are quietly moving toward the next chapter of their story. And that chapter is one of the most spectacular events the cosmos has to offer. Eventually, every star reaches a moment when the quiet balance that sustained it for millions or billions of years begins to fail. The hydrogen fuel at its core, so faithfully converted into helium for nearly its entire lifetime, slowly becomes depleted. At first, the change is almost imperceptible. The star doesn't simply switch off like a light bulb. Instead, gravity, which has patiently been waiting for billions of years, finally begins to gain the upper hand. As the core contracts under its own immense weight, temperatures rise dramatically, becoming hot enough to ignite new forms of nuclear fusion. Helium begins fusing into carbon, carbon into oxygen, and in the most massive stars, an incredible chain of reactions produces neon, magnesium, silicon, sulfur, and many of the other elements that make up the universe around us. In many ways, a star spends its entire life becoming a cosmic factory. Every heavier element requires more energy to create than the one before it, and for millions of years the star patiently builds layer upon layer inside itself, almost like an onion. If you could somehow slice one of these giant stars in half, you would find enormous shells of different elements nested inside one another. Hydrogen surrounds helium, helium surrounds carbon, carbon surrounds oxygen, and so on, with each layer representing another chapter in the star's long life. It is one of the most beautiful structures in astronomy, and yet no human eye has ever seen one directly. We know it exists because the laws of physics describe it so precisely, and because the elements forged inside these stellar furnaces eventually find their way into the universe around us. But every factory has a limit. Deep inside the largest stars, the process eventually reaches iron. Iron is different. Unlike every fusion reaction before it, combining iron atoms does not release energy. It consumes it. To a star, this is a catastrophe. Imagine an enormous steam engine whose fire suddenly goes cold. The machinery may continue moving for a moment, but the force that supported it has disappeared. In much the same way, once a massive star begins producing an iron core, the outward pressure that has resisted gravity for millions of years rapidly weakens. What happens next unfolds with astonishing speed. A star that may have shone peacefully for 10 million years can begin collapsing in less than a second. The core falls inward at an incredible fraction of the speed of light, reaching densities so extreme that atoms themselves are crushed apart. Electrons and protons are forced together to form neutrons, and in the briefest instant, a core once larger than Earth may collapse into an object no bigger than a city. Then, almost unbelievably, the collapse stops. The infalling material slams into this newly formed core and rebounds outward in one of the most violent events the universe has ever produced. The star explodes as a supernova, releasing more energy in a few weeks than our Sun will emit over its entire 10 billion-year lifetime. For a short time, a single dying star can outshine every other star in its entire galaxy combined. Astronomers have recorded supernovae so bright that they were visible during the daytime, even though they occurred thousands of light-years away. These explosions are not simply spectacular, they are essential. The immense temperatures and pressures created during a supernova forge many of the heaviest elements found in nature, including gold, platinum, uranium, and iodine. The gold in a wedding ring, the iodine used by your thyroid gland, and countless other atoms that make life possible were almost certainly created during one of these extraordinary stellar deaths. Every supernova enriches the surrounding galaxy, scattering newly formed elements into vast clouds of gas and dust where future generations of stars, and eventually planets, will begin to form. There is something profoundly beautiful about this cycle. A star spends millions or billions of years creating the raw materials for future worlds, only to return those materials to the galaxy in one final brilliant act. Those clouds slowly drift through space until gravity begins gathering them together once again. New stars ignite. New planets form. Perhaps somewhere among them, life begins. In that sense, the universe is constantly recycling itself. The end of one star becomes the beginning of countless new stories, each carrying within it atoms that have already lived remarkable lives inside suns far older than our own. For centuries, people believed the stars were permanent. They seemed so constant that ancient civilizations used them as reference points to build calendars, navigate oceans, and map the heavens. Entire cultures grew beneath the same constellations, generation after generation, each believing the stars above them were unchanging. It is easy to understand why. A human lifetime is simply too short to notice the slow evolution of a star. To us, the night sky appears almost timeless. But modern astronomy has revealed that the stars are constantly changing. Some pulse rhythmically, expanding and contracting over periods of days or weeks. Others rotate so rapidly that they become slightly flattened at their equators. Powerful magnetic fields twist across their surfaces, occasionally releasing enormous eruptions of plasma that race into space at millions of kilometers per hour. Even our own Sun experiences an 11-year cycle during which its magnetic field gradually twists, weakens, reverses, and rebuilds itself. During the most active years of this cycle, dark sunspots become more common, and violent solar flares can release energy equivalent to billions of hydrogen bombs. These eruptions send streams of charged particles racing toward the planets, and when some of those particles collide with Earth's atmosphere, they create one of the most beautiful natural displays on our planet, the shimmering curtains of green, purple, and red light we know as the aurora. Perhaps even more remarkable is the fact that, although the stars appear scattered randomly across the night sky, nearly every one of them is traveling through the Milky Way at incredible speeds. Our own Sun is orbiting the center of the galaxy at roughly 220 kilometers every second, completing one full journey approximately every 225 million years. The last time our solar system occupied this exact position in the galaxy, dinosaurs had only just begun appearing on Earth. Since then, our planet has witnessed the rise and extinction of countless species, the formation of mountain ranges, the evolution of mammals, and eventually the emergence of humanity. All while the Sun quietly continued its journey around the galactic center. The constellations themselves are only temporary illusions. Orion, Ursa Major, Cassiopeia, these familiar patterns exist solely because we happen to view them from one particular place at one particular moment in history. In reality, the stars that form a constellation are often separated by dozens, hundreds, or even thousands of light years. They are not traveling together through space like members of the same family. They simply appear aligned from Earth's perspective. Given enough time, every constellation will slowly change shape. Millions of years from now, Orion will no longer resemble the mighty hunter recognized by ancient astronomers. New patterns will emerge, while the old ones quietly dissolve into history. This realization becomes even more extraordinary when we remember that looking into the night sky is also an act of looking backward through time. Because light travels at a finite speed, every star we see appears not as it is now, but as it was when its light began its journey. The nearest star beyond our Sun, Proxima Centauri, appears to us as it existed more than 4 years ago. The brilliant blue star Deneb, one of the brightest stars in the Summer Triangle, lies over 2,500 light-years away. The light entering your eyes tonight left that star before the Roman Empire had fallen. Some of the faint stars visible through a telescope may no longer exist at all. They may have exhausted their fuel and disappeared centuries ago, yet their ancient light is only now arriving at Earth, faithfully carrying the final chapters of stories that ended long before human beings ever knew they had begun. It is a quietly humbling thought. The night sky is not a snapshot of the present, but a vast archive of history. Every point of light is a message sent across unimaginable distances, each one arriving after years, centuries, or even millennia of travel. In a sense, astronomers are not only studying stars, they are reading the universe's memory, one photon at a time. As telescopes became larger and more powerful, astronomers began making a discovery that completely changed our understanding of the universe. For thousands of years, every star visible to the naked eye belonged to our own galaxy, the Milky Way. It was natural to assume that the Milky Way was the universe itself, a vast collection of stars stretching across the heavens with little beyond it. Then, in the early 20th century, astronomers pointed their telescopes toward faint, cloudy patches of light that had long been called spiral nebulae. They appeared as little more than delicate smudges against the darkness, and nobody knew exactly what they were. Some believed they were clouds of gas within our own galaxy. Others suspected something far more extraordinary. The answer arrived through the work of astronomer Edwin Hubble. While studying one of these faint spirals, known today as the Andromeda Galaxy, Hubble identified a special type of pulsating star called a Cepheid variable. These stars brighten and dim at remarkably predictable rates, allowing astronomers to calculate their true brightness and, in turn, their distance. When Hubble finished the calculations, the numbers were astonishing. The star wasn't merely distant. It was impossibly distant. Far beyond the edges of the Milky Way. That single observation revealed something humanity had never imagined with certainty before. The fuzzy spiral wasn't a cloud inside our galaxy. It was another galaxy entirely. A vast island of stars containing hundreds of billions of suns, separated from us by millions of light-years. In one moment, the universe became incomprehensibly larger. The stars we see each night are only a tiny fraction of what exists. Beyond them lie countless other galaxies, each filled with their own stars, their own planets, and perhaps worlds no human being will ever witness. Even more remarkably, astronomers now estimate that the observable universe contains hundreds of billions of galaxies. And each galaxy contains hundreds of billions of stars. The numbers become so enormous that our minds begin to lose their meaning. There are likely more stars in the observable universe than grains of sand on every beach on Earth combined. And yet, among all of those stars, our own Sun occupies no special position. It is not unusually large, not unusually bright, not unusually old. In fact, astronomers classify it as an ordinary G-type main sequence star. An average star. One among countless others. There is something strangely comforting about that. Our star does not stand apart because it is extraordinary. It stands apart because it happens to be ours. It is close enough to warm our planet. Close enough to allow liquid water to exist. Close enough to make life possible. If the Sun were only slightly more massive, it would burn hotter and live a much shorter life. If it were significantly smaller, Earth might never have received enough energy for complex life to flourish. By an extraordinary combination of circumstances, our planet formed around a star whose steady, long-lived nature provided billions of years of stability. Long enough for life to begin. Long enough for evolution to unfold. Long enough for creatures capable of wondering about the stars to eventually appear. Perhaps the most poetic realization of all is that the atoms inside your body have already lived remarkable lives before becoming part of you. The carbon that forms your cells may once have been deep inside a red giant star. The oxygen you breathe may have drifted through interstellar clouds for millions of years before becoming part of Earth. The calcium in your bones, the phosphorus in your DNA, and the iron carried through your bloodstream were all forged in stars that disappeared long before our Sun was born. Astronomer Carl Sagan once popularized this idea with a phrase that has since become one of the most beautiful descriptions in science. We are made of star stuff. It is not simply a metaphor. It is a literal description of our origins. Every living thing on Earth carries within it atoms that were created in ancient stars. In that sense, the universe has been recycling itself for billions of years. Stars create the ingredients for planets. Planets create the conditions for life. Life eventually becomes capable of studying the stars that made it possible. There is something wonderfully circular about that story. The universe has, in a way, become aware of itself. Tiny collections of atoms, assembled on a small rocky planet orbiting one ordinary star, have learned to look upward and understand where those very atoms first came from. Perhaps that is one of the most remarkable achievements in all of science. Not simply that we discovered what stars are, but that the stars, through us, have finally gained the ability to tell their own story. One of the most beautiful discoveries in modern astronomy is that stars are rarely born alone. When we picture the night sky, it's easy to imagine each star forming independently, scattered randomly throughout the galaxy like distant lanterns. In reality, stars begin their lives together. Deep within enormous clouds of gas and dust, sometimes stretching hundreds of light-years across, gravity slowly gathers pockets of material into dense clumps. Over hundreds of thousands of years, those clumps collapse, growing hotter and denser until nuclear fusion finally ignites. Yet this process doesn't happen just once. A single giant cloud can give birth to hundreds or even thousands of stars at nearly the same time, creating what astronomers call a stellar nursery. If you have ever seen photographs of the Orion Nebula or the Pillars of Creation, you have looked upon places where stars are being born even now. They are among the youngest regions in our galaxy, vast cosmic nurseries where brilliant newborn stars illuminate the clouds from which they emerged. The light from these young stars carves enormous cavities through the surrounding gas, while powerful stellar winds sculpt the clouds into towering columns and delicate filaments that stretch across trillions of kilometers. The result is so breathtaking that it often resembles a painting more than a real place, yet every glowing cloud, every luminous ridge, and every brilliant point of light is shaped by the same laws of physics that govern our own sun. As astronomers continued studying these stellar nurseries, they realized something equally remarkable. Our own sun almost certainly began its life inside one of them. Around 4.6 billion years ago, somewhere within a giant molecular cloud that has long since disappeared, hundreds or perhaps thousands of young stars ignited together. For a brief period, the sun had countless stellar siblings, all forming from the same cloud of gas and dust. Over the next few 100 million years, gravity slowly pulled the cluster apart. Each star drifted into its own orbit around the Milky Way, scattering in different directions until they became separated by thousands of light-years. Today, astronomers are actively searching for these long-lost siblings. By studying the precise chemical composition of stars, researchers hope to identify others that formed alongside the Sun billions of years ago. Somewhere in our galaxy, there may be stars shining tonight that were born beside our own Sun before Earth even existed. They have spent billions of years traveling different paths around the Milky Way, never crossing our skies in any meaningful way, quietly carrying the same chemical signature they received at birth. Not every star lives in solitude, however. In fact, many of the stars visible in the night sky belong to binary systems, where two stars orbit one another in an intricate gravitational dance. Some even exist in groups of 3 or 4. To anyone standing on a planet within such a system, the sky would be unlike anything we know on Earth. Imagine watching 2 sunsets each evening, or seeing one brilliant star hanging in the sky while another slowly rises beyond the horizon. Depending on the arrangement, shadows might overlap, mornings could arrive in unusual patterns, and the colors of daylight might change as different stars dominate the sky. These worlds are no longer confined to science fiction. Modern telescopes have discovered planets orbiting binary stars, confirming that such systems truly exist. Somewhere in the galaxy, there are landscapes illuminated by multiple suns, where the rhythms of day and night unfold in ways our ancestors could scarcely have imagined. The stars themselves are also far from quiet. While they appear as tiny, motionless points from Earth, their surfaces are unimaginably dynamic. Our own sun is covered in enormous rivers of plasma, constantly flowing beneath powerful magnetic fields. Towering loops of glowing gas can rise hundreds of thousands of kilometers above the surface before collapsing again, while immense convection cells carry hot material upward and cooler material downward in a slow but endless circulation. Some of these cells are larger than Earth itself. In certain massive stars, the turbulence becomes even more dramatic, with stellar winds blasting billions of tons of material into space every second. Over millions of years, these winds gradually reshape the star's surroundings, enriching nearby clouds with newly forged elements and preparing the raw material from which future stars and planets will eventually emerge. It is a quiet reminder that stars are not isolated objects shining against an empty backdrop. They are constantly interacting with the galaxy around them, influencing environments hundreds of light-years away and contributing to an ongoing cycle that has continued since the earliest days of the universe. Perhaps the most humbling realization is that, despite everything humanity has learned, we are still only beginning to understand these extraordinary objects. Every year brings new discoveries. Astronomers detect stars with magnetic fields stronger than anyone expected, observe mysterious patterns of brightness that challenge existing theories, and uncover entirely new classes of stellar behavior. Even the Sun, the star we know better than any other, continues to surprise researchers with questions about its magnetic activity, its internal structure, and the processes that generate its enormous energy. For all the equations we've written and all the telescopes we've built, the stars remain wonderfully mysterious. They have illuminated the night sky for billions of years before the first human ever looked upward, and they continue shining with stories that science is still patiently learning to read, one observation at a time. One of the most surprising discoveries about stars is that they can actually ring. Of course, there is no sound in the vacuum of space, so these vibrations would never reach human ears. But stars are constantly oscillating, expanding and contracting by tiny amounts as waves of pressure travel through their interiors. For decades, astronomers could only observe subtle changes in a star's brightness without fully understanding what caused them. Today, an entire field known as astroseismology studies these stellar vibrations in much the same way that seismologists study earthquakes on Earth. By measuring the incredibly small rhythmic changes in a star's light, scientists can determine its age, its size, the speed at which it rotates, and even what its hidden interior looks like. It's an astonishing idea. We cannot travel inside a star, and we cannot see through its brilliant surface, yet by studying the gentle rhythm of its pulsations, astronomers can map structures buried millions of kilometers beneath layers of glowing plasma. In many ways, stars reveal their secrets through music, not music that we hear, but music written in light. That ability to study the inside of a star has transformed astronomy. Before these techniques were developed, scientists could only estimate the internal structure of distant suns using mathematical models. Now they can compare those models with real observations, refining them with extraordinary precision. Some stars pulse every few minutes. Others take days. Each rhythm is slightly different, almost like a fingerprint unique to that individual star. If you were somehow able to convert these variations into audible sound, each star would produce its own haunting tone. Some researchers have even done exactly that, translating the oscillations into frequencies humans can hear. The result is strangely beautiful, a deep, ethereal hum that reminds us these seemingly silent objects are constantly in motion, vibrating with energy that has traveled across space for hundreds or thousands of years before finally reaching our telescopes. As our understanding improved, astronomers also realized that stars have remarkably different personalities. Some live quiet, predictable lives like our Sun, steadily converting hydrogen into helium for billions of years with only occasional bursts of activity. Others are far more unpredictable. There are stars known as flare stars that erupt without warning, releasing enormous explosions of radiation many times more powerful than anything our Sun has ever produced. A planet orbiting too close to one of these restless stars would endure repeated blasts of high-energy particles capable of stripping away atmospheres and dramatically altering any chance for life. This has become one of the central questions in the search for habitable worlds. It's no longer enough for a planet to exist at the right distance from its star. Astronomers must also ask whether the star itself is calm enough to provide a stable environment over billions of years. In many ways, finding another Earth begins with finding another Sun, not simply in size or temperature, but in temperament. Perhaps one of the most remarkable achievements of modern astronomy is that scientists can determine what stars are made of without ever touching them. At first glance, this seems impossible. The nearest star beyond our Sun is more than 4 light-years away, far beyond the reach of any spacecraft humanity has ever built. Yet in the 19th century, physicists discovered that every chemical element absorbs and emits light at its own unique set of wavelengths. When the light from a star is passed through a prism or a spectrograph, it spreads into a rainbow crossed by countless dark lines. These lines act like barcodes, each corresponding to a particular element. Hydrogen leaves one pattern, helium another. Sodium, calcium, iron, carbon, and oxygen all produce their own unmistakable signatures. Simply by studying these delicate fingerprints in starlight, astronomers can identify the elements present in a star's atmosphere with extraordinary accuracy. It is one of the most elegant techniques in all of science. From unimaginable distances, without collecting a single physical sample, we can determine the chemistry of objects that exist hundreds or even thousands of light-years away. This technique has also led to one of astronomy's greatest surprises. When scientists began comparing stars throughout the Milky Way, they discovered that younger stars generally contain more heavy elements than older ones. At first, this seemed puzzling, but the explanation revealed the history of our galaxy itself. The earliest stars formed from almost pure hydrogen and helium left behind by the Big Bang. As those stars lived and died, they enriched the galaxy with heavier elements forged inside their cores. The next generation of stars formed from that enriched material, inheriting greater amounts of carbon, oxygen, silicon, iron, and countless other elements. Generation after generation, the galaxy slowly became more chemically complex. In other words, the Milky Way has been evolving for billions of years, each generation of stars quietly leaving gifts behind for the next. Our own Sun belongs to one of these later generations, formed from material that had already passed through the lives of many ancient stars. Every atom of calcium in your teeth, every atom of phosphorus in your DNA, and every atom of iron carried through your bloodstream tells part of that galactic story. A story written across billions of years, in which countless forgotten stars lived, shone brilliantly, and quietly gave their matter back to the universe so that new stars, new planets, and eventually new life could one day emerge. There is another remarkable truth about the stars above us, one that is almost impossible to appreciate without thinking on a truly cosmic scale. Although the night sky appears full, what we actually see is only a tiny fraction of the stars that surround us. On a perfectly dark night, far from the glow of cities, the human eye can detect roughly 5,000 or 6,000 stars across the entire sky. It feels like an overwhelming number until you remember that our Milky Way galaxy alone contains somewhere between 100 and 400 billion stars. Imagine standing on the shore of an enormous ocean and believing you had seen every drop of water because you could count the waves breaking at your feet. That is roughly how much of our galaxy we can see with our own eyes. The overwhelming majority of stars are simply too distant or too faint for human vision, quietly shining beyond the limits of our perception. It is a gentle reminder that the universe is always larger than it first appears. As telescopes became more powerful, astronomers discovered something even more astonishing. Many of the stars scattered across the night sky are not alone, they have planets of their own. For thousands of years, humanity wondered whether other worlds existed, but it wasn't until the 1990s that the first planets orbiting ordinary stars were finally confirmed. Since then, thousands of exoplanets have been discovered, and with every passing year the number continues to grow. Some are scorching worlds where molten rock flows across the surface beneath skies hotter than lava. Others are frozen giants drifting through perpetual darkness. There are planets so large they would dwarf Jupiter, and others only slightly bigger than Earth. A few even orbit within what astronomers call the habitable zone, where temperatures might allow liquid water to exist. When you look up at the stars tonight, it is no longer imagination to wonder whether worlds circle them. We know they do. Nearly every star in the sky is now thought to host at least one planet, and many host entire families of worlds, each with its own history unfolding silently around its parent star. Some of these distant solar systems are unlike anything found in our own corner of the galaxy. Astronomers have discovered planets orbiting two stars at once, much like the fictional world of Tatooine from Star Wars, where two sunsets would grace the evening sky. Others orbit so close to their stars that a year lasts only a few Earth days, while some travel on enormous elongated paths that carry them alternately into intense heat and bitter cold over the course of a single orbit. There are planets with skies likely filled with silicate clouds, where droplets of molten rock may condense high in the atmosphere before falling back toward the surface. On others, fierce winds may race across the globe at thousands of kilometers per hour, driven by the immense energy pouring from nearby stars. The diversity of planetary systems has taught astronomers an important lesson: our solar system is only one way of arranging a family of worlds. Nature has imagined far stranger configurations than we ever expected. As researchers continued studying stars, they found that even their motion could reveal invisible objects hidden nearby. Every planet, no matter how small, exerts a tiny gravitational pull on its parent star. We often picture planets orbiting stars, but in reality both objects orbit a shared center of mass. For a massive star and a small planet, the star barely moves at all, only a subtle wobble, almost imperceptible against the vastness of space. Yet modern instruments are so extraordinarily precise that astronomers can detect this gentle motion from dozens or even hundreds of light years away. By measuring these tiny wobbles, they can estimate the planet's mass, its orbit, and sometimes even whether additional planets are present in the same system. It is astonishing to think that an invisible world, too faint to see directly, can reveal itself simply by the gentle tug it exerts on its distant sun. Perhaps the most poetic method of discovering planets occurs when one of them happens to pass directly in front of its star. For a few brief hours, the planet blocks an incredibly small fraction of the starlight, causing the star to dim ever so slightly. The change is almost unbelievably subtle. Imagine noticing that a lighthouse several hundred miles away had become just 1% dimmer for a short time. Yet space telescopes such as Kepler have measured these tiny decreases in brightness with extraordinary precision, discovering thousands of new worlds in the process. Every small dip in starlight tells a story. Somewhere across the galaxy, a planet quietly crossed the face of its sun, and after traveling through space for perhaps hundreds of years, that slight change in brightness finally reached our telescopes. Entire planetary systems have been uncovered from nothing more than these delicate flickers of light. The more astronomers learn about stars, the more they realize that they are not merely distant lights decorating the night sky. They are the architects of planetary systems, the engines that shape galaxies, and the reason worlds like our own can exist at all. Around them, planets are born, atmospheres evolve, oceans may form, and perhaps, on rare occasions, life begins asking questions about the stars that gave it light. It is a beautiful cycle that has repeated throughout the Milky Way for billions of years, and as our telescopes continue improving, each new discovery reminds us that the night sky is not simply filled with stars. It is filled with possibilities, each point of light perhaps illuminating another world, another horizon, and another story waiting to be discovered. Among the billions of stars scattered throughout the Milky Way, there are some so unusual that, if they were placed where our sun now sits, the night sky would become almost unrecognizable. One of the most famous is a class of stars known as neutron stars. They are not particularly large, in fact, they are astonishingly small. A typical neutron star measures only about 20 kilometers across, making it roughly the size of a city. Yet within that tiny sphere is packed more mass than our entire Sunday. The material inside is compressed so intensely that a single teaspoon of neutron star matter would weigh billions of tons on Earth. To put that into perspective, a piece no larger than a sugar cube would outweigh Mount Everest. These objects challenge our intuition because they combine immense mass with incredibly small size, creating some of the strongest gravitational fields anywhere in the universe outside of black holes. Neutron stars also rotate at extraordinary speeds. When the core of a massive star collapses during a supernova, it conserves its angular momentum in much the same way an ice skater spins faster by pulling in their arms. A star that once rotated leisurely over many days can suddenly shrink into a neutron star spinning dozens or even hundreds of times every second. Some of the fastest, known as millisecond pulsars, complete more than 700 rotations every second. Imagine standing on the surface of an object where sunrise and sunset occurred hundreds of times before you could blink. These rapidly spinning stars often emit narrow beams of radio waves from their magnetic poles. As the star rotates, the beams sweep across space like the light from a lighthouse. If one of those beams happens to cross Earth, astronomers detect an incredibly precise pulse of radio energy. So regular are these pulses that, before they were understood, some scientists briefly wondered whether they might be signals from an intelligent civilization. The first discovered pulsar was even jokingly labeled LGM-1, short for the Little Green Men. It didn't take long to realize the true explanation was even more fascinating: a dead star, spinning with astonishing precision, sending rhythmic signals across the galaxy. Stars also exist that push the limits of brightness itself. One of the most luminous known stars, Eta Carinii, radiates several million times more energy than our Sun. During the 19th century, it unexpectedly brightened so dramatically that it briefly became the second brightest star visible in Earth's night sky, despite lying about 7,500 light-years away. Astronomers still debate exactly what happened during this event, known as the Great Eruption. Rather than exploding completely, the star somehow survived after ejecting an enormous amount of material into space, creating the spectacular glowing cloud known today as the Homunculus Nebula. Even now, Eta Carinii remains unstable, and many astronomers believe it is destined to end its life in an enormous supernova sometime within the next million years. While that may sound imminent in astronomical terms, it is reassuringly distant on a human timescale. If it were to explode tomorrow, the event would be spectacular to observe from Earth but far too distant to pose any danger. Not all stars are born with the same chemical ingredients, and this difference allows astronomers to reconstruct the history of entire galaxies. Older stars, formed when the universe was still young, contain relatively few heavy elements because those elements simply had not been created yet. Younger stars inherit the enriched material left behind by generations of earlier stars, making them richer in carbon, oxygen, silicon, iron, and countless other elements. In effect, every star carries a chemical record of when it was born. By studying these chemical fingerprints, astronomers can identify some of the oldest surviving stars in the Milky Way, ancient objects that formed more than 13 billion years ago, when the universe itself was still in its infancy. These stellar elders have quietly orbited our galaxy ever since, shining continuously through the formation of galaxies, the birth of the Sun, the rise of life on Earth, and every moment of human history. Perhaps the most extraordinary realization is that, despite their immense size and incredible power, stars are surprisingly efficient at sharing their stories with us. Every beam of starlight carries information. The color reveals temperature. The brightness hints at size and distance. Tiny shifts in wavelength reveal motion. Dark absorption lines uncover chemical composition. Gentle pulsations expose the hidden structure deep within the core. Even the faintest wobble can betray the presence of unseen planets. It is remarkable that something as simple as light, traveling patiently across the emptiness of space for years or even millennia, can tell us so much about an object we may never physically reach. In many ways, astronomy is less about looking at stars than it is about learning to read the messages they have been sending all along. Every clear night, those messages continue arriving silently overhead, crossing unimaginable distances until, for a brief moment, they end their journey in the eyes of someone willing to look up and wonder. As the 20th century drew to a close, astronomers began noticing something peculiar about the stars themselves. Not every star in the sky was destined to remain where it was. In fact, many of them are racing through the galaxy at astonishing speeds. One of the fastest ever discovered, known as a hypervelocity star, is traveling so quickly that it will eventually escape the gravitational pull of the entire Milky Way. Scientists believe these stellar runaways are often created during dramatic encounters with the supermassive black hole at the center of our galaxy. Imagine a pair of stars orbiting one another as they wander too close to this enormous black hole. The immense gravitational forces can tear the pair apart, capturing one star while flinging the other outward like a stone released from a slingshot. Some of these stars travel at millions of kilometers per hour, embarking on lonely journeys that may carry them into the vast emptiness between galaxies. Long after the Milky Way has disappeared behind them, they will continue drifting through intergalactic space, accompanied only by the faint light of distant galaxies. At the opposite end of the scale are stars that barely move at all from our perspective. One such star is Paul Aries, commonly known as the North Star. For centuries, travelers relied on it to navigate across oceans, deserts, and forests because it appears almost perfectly fixed in the northern sky while every other star seems to circle around it during the night. Yet even Polaris is not truly stationary. It is simply aligned very closely with Earth's rotational axis at this particular moment in history. Thousands of years ago, another star occupied that privileged position, and thousands of years from now a different one will take its place. Earth's axis slowly wobbles like a spinning top, completing one full cycle approximately every 26,000 years. This slow motion, known as axial precession, gradually changes the identity of the North Star. Ancient Egyptian builders, the sailors of the age of exploration, and people living thousands of years in the future all navigate beneath slightly different skies, even though the stars themselves have changed very little. Astronomers have also discovered stars that seem to have survived events that should have destroyed them completely. In recent years, telescopes have recorded mysterious stellar explosions that brighten dramatically before fading away, only for the original star to remain visible afterward. These unusual events, sometimes called supernova imposters, resemble genuine supernovae from a distance but are far less destructive. Instead of completely tearing the star apart, they eject enormous shells of gas into space while the star somehow survives beneath the expanding cloud. Why certain massive stars behave this way remains one of the unanswered questions in stellar astronomy. It is another reminder that nature often refuses to fit neatly into the categories we create. Just when scientists believe they understand how stars live and die, the universe quietly presents another exception. One of the most elegant discoveries in modern astrophysics is that stars reveal their ages much like trees do. A tree grows rings that preserve a record of wet years, dry years, fires, and changing climates. Stars leave no such visible rings, yet their chemistry slowly changes over billions of years as hydrogen in the core is converted into helium. Combined with precise measurements of a star's temperature, brightness, mass, and subtle oscillations, astronomers can estimate its age with remarkable accuracy. Some stars in our galaxy are only a few million years old, cosmic infants that have barely begun their lives. Others have been shining for more than 13 billion years, making them among the oldest surviving objects in the universe. These ancient stars formed when galaxies themselves were still young, long before the Sun existed, quietly preserving a record of conditions that no telescope could otherwise observe. Looking at one of these stellar elders is rather like opening a history book whose first pages were written near the beginning of time itself. Perhaps the most astonishing fact of all is that stars have profoundly shaped nearly everything we know, even though they are separated from us by unimaginable distances. Every breath of oxygen you take depends on ancient stars that forged the atoms long before Earth formed. Every green leaf owes its existence to sunlight produced by nuclear fusion 93 million miles away. Every meal you've ever eaten ultimately traces its energy back to a star. Even the fossil fuels buried deep beneath Earth's surface are simply ancient sunlight stored by plants hundreds of millions of years ago. In a very real sense, almost every form of energy that powers life on our planet has its origin inside a star. The warmth of a summer afternoon, the food on our tables, the forests that cover mountainsides, and even the beating of your own heart all exist because one ordinary yellow star has quietly continued shining for billions of years. When you step outside on a clear evening and look toward the heavens, it is easy to feel as though the stars are unimaginably distant, disconnected from the world beneath your feet. Yet the deeper science looks, the more that illusion disappears. The stars are not merely decorations scattered across the night sky. They are the reason chemistry became complex enough for life to exist. They are the architects of planets, the creators of the elements, and the silent engines that have shaped the history of the universe from its earliest chapters until this very moment. Every point of light above you is both a destination and a storyteller, carrying within it the history of billions of years, patiently waiting for curious minds to read the tale written in its light. There is one final mystery about stars that astronomers have spent decades trying to unravel, and it begins with a surprisingly simple question. How do you weigh something that you can never place on a scale? A star may be hundreds or thousands of light-years away, impossibly beyond our reach, yet knowing its mass is one of the most important pieces of information in all of astronomy. The mass of a star determines almost everything about its future. It dictates how bright the star will shine, how hot it will become, how long it will live, and ultimately how it will die. For many years, scientists struggled to answer this question, until they realized that nature itself had already provided the solution. The answer lay in binary stars. When two stars orbit one another, they are engaged in a delicate gravitational dance, each responding to the other's pull. By carefully measuring the time it takes for them to complete an orbit and observing the paths they trace through space, astronomers can apply the same laws of gravity that describe the motion of planets around the Sun. Without ever touching either star, they can calculate their masses with astonishing precision. It is one of the great triumphs of physics that equations first developed to explain falling apples and orbiting moons can also be used to weigh distant suns scattered across the galaxy. Every binary star system becomes a natural laboratory, quietly revealing secrets that would otherwise remain hidden forever. As telescopes grew even more sensitive, astronomers noticed another curious phenomenon. Some stars seem to disappear for a short time before returning to normal brightness. At first glance, it looked as though something mysterious was happening within the stars themselves, but the explanation turned out to be even more exciting. In many cases, an unseen companion star was passing directly in front of the other from Earth's perspective, briefly blocking part of its light. These systems, known as eclipsing binaries, have become some of the most valuable objects in astronomy. By studying the precise timing of these eclipses, scientists can determine the stars' sizes, temperatures, densities, and even the shapes of their orbits. Every tiny dip in brightness becomes another clue, another piece of a puzzle assembled from nothing more than patiently observed starlight. Not all stars remain faithful to a single companion. In dense star clusters, where hundreds of thousands of stars are packed into relatively small regions of space, close encounters occur far more frequently than they do in the quiet neighborhoods surrounding our Sun. Gravity gently reshuffles the stars over millions of years. Some companions are exchanged. Others are ejected entirely. Entire stellar families are rearranged through countless close encounters, creating a slow cosmic choreography that unfolds far too gradually for human eyes to witness directly. Computer simulations allow astronomers to compress millions of years into just a few minutes, revealing star clusters as surprisingly dynamic places where stars drift, interact, and migrate through an endless gravitational dance. Perhaps the most beautiful stellar gatherings are the globular clusters that surround our galaxy like ancient jewels. These nearly spherical collections may contain several 100,000 stars, all packed into a region only a few hundred light-years across. Many of them formed more than 12 billion years ago, making them among the oldest surviving structures in the Milky Way. If you could stand on a planet inside the center of one of these clusters, the night sky would be almost beyond imagination. Instead of a few thousand visible stars, tens of thousands would blaze overhead with a brilliance unknown on Earth. Some would appear bright enough to cast shadows. The familiar darkness between the stars would nearly disappear beneath an endless sea of light. Yet despite this extraordinary beauty, globular clusters remain strangely quiet places. Their stars are so old that many of the massive blue giants have long since vanished, leaving behind populations of smaller, cooler stars that have continued shining faithfully since the earliest days of the universe. As astronomers have pieced together these discoveries, they have come to appreciate that every star carries two stories at once. One is the story of the star itself. Its birth inside a cloud of gas, its long struggle against gravity, and the extraordinary events that will eventually mark its final chapter. The other story is written in the lives of everything around it. Planets form within disks of dust left over from its creation. Comets and asteroids preserve frozen remnants of those early days. Oceans may appear on rocky worlds warmed by its light. Chemistry grows more complex. Life, perhaps, begins asking questions about the universe that produced it. In this way, stars are not simply objects to be studied. They are the starting points for entire worlds, entire histories, and perhaps countless civilizations scattered throughout the cosmos. It is remarkable to think that somewhere tonight, beneath the glow of another distant sun, there may be someone else looking upward with the very same sense of curiosity. Their constellations would be different. Their sky unfamiliar. Their star perhaps redder, brighter, or older than our own. Yet they too would be living beneath the quiet light of a star, wondering where it came from, how long it would shine, and what other lights might exist beyond their horizon. The stars have inspired those questions for as long as conscious beings have looked into the night, and perhaps that is their greatest gift. Long before they taught us physics, chemistry, or astronomy, they taught us something even more important, the desire to wonder. And so, as our journey among the stars slowly comes to an end, the night sky grows quiet once again. Imagine yourself lying beneath that same blanket of darkness where we began. The air has become cooler. The world around you has settled into silence. Above you, the stars continue shining just as they have every night for billions of years. At first glance, they seem unchanged. Timeless. Almost eternal. Yet now you know their true story. You know that every one of those distant lights is alive with extraordinary activity. Deep within each star, gravity and nuclear fusion remain locked in a delicate balance. Atoms are being forged into new elements. Light is beginning journeys that may last hundreds, thousands, or even millions of years before reaching another world. Some stars are only just opening their eyes for the first time inside glowing nebulae, while others are quietly approaching the final chapters of lives that began long before Earth itself existed. You know that the stars above you are not isolated points of light. They are families. They are nurseries. They are travelers, drifting through the Milky Way on journeys that span hundreds of millions of years. Some race toward the edge of the galaxy, while others have remained faithful companions for billions of years. Around many of them, planets quietly circle in the darkness, each illuminated by its own sunrise beneath an unfamiliar sky. Perhaps on one of those distant worlds, another curious mind has looked upward and wondered exactly the same things we have wondered tonight. It is a comforting thought. That curiosity itself may be as universal as the stars. We often think of the universe as unimaginably large, and of ourselves as unimaginably small. And in one sense, that is true. The stars have witnessed events almost beyond comprehension. They have watched galaxies collide, planets form, and generations of suns rise and fade away. They have existed through stretches of time so immense that the entirety of human history occupies only the smallest fraction of their lives. Yet despite those enormous differences in scale, there is also a quiet connection between us. The calcium in your bones was forged inside a star. The oxygen filling your lungs was created by another. The iron carried through your bloodstream was born during the final moments of a star that disappeared billions of years before our sun ever existed. Every breath you take carries with it a history older than our planet. Every heartbeat is powered by atoms that once glowed deep inside ancient suns. The stars are not simply above us. In a very real sense, they are within us. Perhaps that is why looking at the night sky has always stirred something deep inside the human spirit. Long before telescopes, long before mathematics, long before we understood gravity, fusion, or galaxies, people looked upward with the same sense of wonder. They told stories, created constellations, used the stars to find their way across deserts and oceans. They may not have known what stars truly were, but they recognized something we still feel today. That the night sky invites us to pause, to become still, to remember that we are part of something far larger than ourselves. Science has not taken away that feeling. If anything, it has deepened it. Because now we know that every tiny point of light carries an entire history within it. A history of birth, change, transformation, and renewal. The universe is not a collection of separate objects. It is one continuous story. Clouds become stars. Stars create elements. Elements become planets. Planets give rise to oceans, forests, mountains, and living creatures capable of asking where they came from. And those creatures eventually discover that they, too, are part of the star's story. There is something beautifully circular about that. The universe spent billions of years creating stars. The stars spent billions of years creating the ingredients for life. And life eventually became capable of looking back toward the heavens with understanding and gratitude. As you settle a little deeper into your chair, or beneath your blanket, imagine those distant suns continuing their silent work long after tonight has passed. Some of the light leaving their surfaces at this very moment will not arrive at Earth until long after our own lives have become part of history. Other photons are only now completing journeys that began before human civilization existed. The universe is constantly exchanging these quiet messages across the darkness. Patiently, faithfully, without hurry. The stars ask for nothing in return. They simply shine, as they always have, and as countless of them always will. Thank you for joining me on tonight's journey through the remarkable science of stars. I hope you've enjoyed wandering through these ancient lights, discovering not only how they live and die, but how deeply connected they are to every living thing on Earth. Until our next adventure together, sleep well, stay curious, and the next time you find yourself beneath a clear night sky, take just a moment to look up. Some of the light reaching your eyes began its journey before history was written. Some before humanity even existed. And somewhere among those countless stars are the ancient suns whose final gifts became the atoms that make you who you are today. Good night.